This is calculus video for section 1.5 notes. And this is more logarithms, not really sure. Kind of some of this is a little bit repetitive with 1.3. You'll notice we skipped 1.4. We don't do 1.4 in AB. So we're going to talk about one-to-one functions in this section. We're going to talk about, once again, representing something algebraically and graphically, and we're going to talk about inverses. This parametric equations were 1.4, so we're actually not going to do that, where we talk more about parametrics. Properties of logs and using log regression equations to solve problems. Okay, so definition of one-to-one. What you want to know about one-to-one is it says if A does not equal B, so think of these as two x's, two inputs, then your outputs don't equal each other. What this looks like in a graph is it passes the vertical line test, and remember, if you pass the vertical line test, then you're a function. A one-to-one function also passes the horizontal line test. So if you have a graph, the easiest way to check for one-to-one is see if it passes the vertical and horizontal line test. Vertical means it's a function. Vertical and horizontal means it's a one-to-one function. So this is our function, absolute value of x. So hopefully this is the picture that immediately pops up into your head. This is the absolute value graph, and you can look at it right away and say, well, that does not pass the horizontal line test, so this is not one-to-one. Okay, and then if you think about the definition, say I picked these 2 points, -2 and 2, so -2 does not equal 2. However, f of -2 does equal f of +2. Okay, so that also shows that it's not one-to-one, because f of -2 is going to be +2, and f of +2 is going to be +2. All right, square root. Remember, hopefully this picture is popping into your head. And if you look at that, you can think, yeah, that's going to pass vertical and horizontal line test. So this is, yes, it is one-to-one. And if you think, I don't know, if you pick any two x's, you know, if x is 1, f of 1 is going to be the square root of 1, and if f of 2 is going to be the square root of 2. You're never going to have a situation where your output is the same for two different inputs on the square root function. You're taking the square root of a number. The answer is always going to be two different numbers. All right, now inverses. Little review on inverses. So the definition is the function defined by reversing a one-to-one function, f, and finding its inverse. So for x and y, say you had, I don't know, I'm just going to make up some points here. Say you had this for your function. The inverse of that function would look like this: 2, 1, 4, 3, 6, 5. So your x's and y's flip. 1, 2 becomes 2, 1. The coordinate point 1, 2 becomes the coordinate point 2, 1. You cannot see that. I need to slide my paper up. There you go. So this is the easiest way to think about inverses is x and y switch. The other way to think about it is if you compose an inverse inside of its inverse. So these, think f and g are inverses of each other. So if you compose them both ways, you're going to get x for your output. So that's also another way of showing that you have inverses. So f and g are inverses. If f and g are inverses, then f of g of x and g of f of x, you're going to get equals x for both of those. So writing f inverse as a function of x. This is how you identify an inverse. So if this is your function, this is how you identify the inverse of the function. So there's some steps. You did it in Algebra 2. Solve the equation y equals f of x for x in terms of y. That sounds really confusing, but once we do it, it won't be. Interchange x and y. The resulting equation will be f inverse. So think of this, x becomes y and y becomes x when you're doing this. So solve this function is, show that it's one-to-one and find its inverse. Well, first of all, this is a line, okay? So lines, it's a line with a slope. So lines are always going to be one-to-one. So this is a line with a y-intercept of 4 and a slope of -2. So I'm going to go down 2 over 1, right? So it's going to be a slanty line. So this is going to be one-to-one. Passes vertical and horizontal line test. And if I did, for example, f of 2, I would get 0. If I do f of -2, I'm going to get 8. So when a does not equal b, f of a does not equal f of b. So is one-to-one. Now we need to find its inverse. So the first thing you want to do is if your function is written as f of x equals like that, you want to write it as y equals. Okay? And then you want to solve for x. So you want to get x alone. We're normally getting y alone. We want to get x alone. So I would -4 from both sides. Y minus 4 equals -2x. And then if I want x alone, I want to divide everything by -2. So I'm going to write this as -1/2 y plus 2 equals x. Okay, now this is where you want to think of the switch x and y part. So I want to write this y as an x, and this x as a y. So now this is my inverse function. To clearly identify it as the inverse of f of x, I want to write it as f inverse of x. Okay? So that is f inverse of x. So if I wanted to verify it was f inverse of x, I could do this composition, right? So I could put f inverse of x inside of f of x, which was this, what I started with. So I want to replace this x with this function, f inverse inside of f of x. Okay, so instead of, I'm going to have the -2, instead of x, I'm going to put my f inverse inside of there. So I'm replacing this x with all of this, and then +4, and then simplify this. Negative times a negative is a positive. Half of 2 is 1, so that's just going to be x minus 4 plus 4. So I get x. So that looks good. Now let's compose it the other way. So this time I'm going to put f inverse on the outside and f of x on the inside. So this is f inverse. This is going to go on the outside, and I'm going to replace this x with -2x plus 4. So I'm going to start out with this -1/2. When I get to this x, I'm going to replace it with -2x plus 4, and then the +2 hangs off the end. Okay, so half of 2 again is just 1, or 1x. Half of +4, negative times a positive is a negative. Half of 4 is 2, so I get +2 minus 2, so I get x. So this shows that this is the inverse of that. All right. Turn the page. And example 1 here says, graph the one-to-one function f of x equals x squared. Notice this is only where x is greater than or equal to 0, so only where x's are positive, together with the line y equals x only where x is positive, so we're over here on the right side of the coordinate grid. So that's A. And then B says express the inverse of f as a function of x. So this is another way of saying find the inverse of f. Okay, so y equals x squared when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. So this is for only positive x's. This is f of x equals x squared. Should be very, very familiar with that function. And then it wants us to graph this line y equals x, which I'm going to do in a different color. This is the diagonal line that cuts the coordinate grid in half. I'm going to make it go down here where the negatives are, just so it's a little easier to draw. So this is the line y equals x. Okay. The reason why we're drawing this line is because inverses are reflected about the line y equals x. So whenever you find a function, if you want to find its inverse, add in the line y equals x and flip it or reflect it about the line y equals x. So I'll show you how this works. So we want to find the inverse of f of x equals x squared. First write it as y equals x squared and then solve for x. So how do I get rid of a 2 to the second power? I square root both sides. So I'm going to have this. And remember, when you square root of both sides, you need to add in that plus and minus. So square root and 2 to the second power are inverses of each other, so they undo each other. So I'm just left with x here equals the square root of y. The reason I can just use the positive is because we started out saying we're just talking about where x is positive. So I'm just going to keep the positive square root of y. And now I want to switch x and y. This is going to be square root of x equals y. Now I want to write it as the inverse of x. So this is the inverse of x squared expressed as a function of x. Okay, there it is. It's the square root function, right? And that makes sense because to undo a second power, you take the square root. To undo a square root, you raise it to the second power. Inverses, when you're solving algebraically, are what you use to undo something. All right, so now let's graph the square root. Square root of 0 is 0. Square root of 1, we'll get a decimal here. Oh, never mind. Square root of 1 is 1. I was thinking square root of 2 is the one I wanted to put in the calculator. Square root of 2, about 1.5. So over 2, up 1.5. Square root of 4 is 2. You guys know this is going to take this shape. Okay, so you can, this does kind of look like this, flipped over the line y equals x. That's true of all inverses. All right, logs. I'll start this. We'll go through these properties. Properties of log. So definition, this is a log base a of x. So this is the function y equals log base a of x. Remember, base is the little number down here. Is the inverse of this function. So logs and exponentials are inverses. And when I teach this in Algebra 2, when I'm teaching going back and forth between logs and inverses, I use this arrow method. Base always stays the same. So this becomes, they have this written, well, that's okay. They have this written a little differently. Let me put an example in here instead. So I'm going to say log base 2 to the third equals x. So if I wanted to convert this to an exponential, it would be 2 to the x equals 3. Okay, so the bases always stay the same. This is an exponential base 2, log base 2. First arrow is everything on the left side of the equal sign. Second arrow is everything on the right. 2 to the x equals 3. So this would be, you kind of have to go backwards here, a to the y equals x, but then they did the switch x and y like we do up here when we're finding the inverse. Okay, so there's these properties that go with logs, and they're actually down here. So I'm going to talk about the properties here, and then I think I'll go back and do these. So the product rule says log of a times b, so there's the product multiplication, becomes log of a plus log of b. Okay, so these bases I've not written in here. Remember, if the base isn't written, it's a log base 10. Okay, and then quotient is log of a divided by b. There's your quotient. Is the same as log of a minus log of b. So multiplication makes things bigger, so this becomes addition. Division makes things smaller, so this becomes subtraction, top minus bottom. And then the power rule is log of a to the b becomes b times the log of a. So this b goes down out in front here, if you want to think about it that way. All right, now let's look at these, and they're asking me to solve for x. Well, the first thing I want to notice is this is natural log, and remember e to the x and natural log of x are inverses. So natural log has a base e, but we don't write it. Okay, so there's a couple of ways to solve this. I would always convert this to an exponential. So you can do the rewrite, e to the 3t plus 5 equals x. So I just rewrote it, just like I did up here, as an exponential. So this is what x is equal to. You may have learned raise both sides to e. So I'm going to say or. This would be, if I raise both sides to base e, I would have this, and e and natural log are inverses, so these undo each other. So I'd be left with x equals e to the 3t plus 5. I personally prefer this method. If you're undoing a log, you convert it to an exponential. Always works for all logs and natural logs. And this one, if you're undoing an exponential, you want to convert it to a log. So this would be, I'm going to write it like this. No, I'm not going to write it like that. I'm going to say this is, so this is kind of like something like that. So to convert this, I use the arrow method again, but this would be log base 2 of 4 equals x. Okay, so this is log base e, which is natural log, of 10 equals 2 to the x. Okay, so the arrow method works for going from an exponential to a log also. Put a little line in here. Now remember, I'm solving for x, so to get x alone I need to divide both sides by 2. So I have natural log of 10 divided by 2 equals x. Okay, so this is a little review. These are a couple specific problems. I think I'm going to finish this in a second video.